Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 4-1 for May, June 2023, Part 1 for questions 1 to 4. Question 1, this is coming from momentum. Two particles P and Q of masses m kilograms and 0.3 kilograms respectively are at rest on a smooth horizontal plane. P is projected at a speed of 5 meters per second directed towards Q. After P and Q collide, P moves with a speed of 2 meters per second in the same direction as it was originally moving. Find in terms of m the speed of Q after collision. I can look at my particles here. I have P, whose mass is m kilograms, and then we have Q here, whose mass is 0.3 kilograms. So they are on this smooth plane here. And then after collision, we see that, of course, when P knocks Q, it has to move in that direction. So there are two scenarios here, by the way. When P knocks Q, it can rebound or it can move forward. But here they have told us that P continues in the same direction as it was originally moving. And if it rebounds, that happens when the mass of P is less than the mass of Q. Okay? P cannot be heavier than Q and then it rebounds. You see that? So we shall get here m kilograms, then 0.3 kilograms. So we can see that Vp, okay, the velocity of P after collision is 2 meters. It is going in this direction, 2 meters per second. And then that of Q, we don't know it. Okay. And then U of P here is 5. It was projected with a speed of 5 meters per second going forward. And U of Q here, of course, is 0 because it is stationary. Then we use the principle of conservation of momentum. And momentum, you know, it is the product of mass and velocity. So mass of P, momentum before collision, okay, is equal to momentum after collision. So mq uq then is equal to mp vp plus mq vq. Then we have the mass of P is m, and then that its speed is 5. So we shall have here 5m. Automatically here we shall have 0, and then here we shall have 2m, and then plus the mass of Q is 0.3, then VQ. So meaning our VQ is going to be 5m minus 2m out of 0.3m. So, no, out of 0.3. We don't have m on it. So this is the same as saying 2m. I mean 3m. So it's 3m, then divide by 3 over 10. So this one will somersault. Automatically your answer is going to be 10m. So VQ is equal to 10m meters per second. And they said we give it in terms of m. So that is it. After collision, Q moves directly towards a third particle R of mass 0.6 kilograms, which is at rest on the plane. Q is brought to rest in the collision with R, and R begins to move with a speed of 1.5 meters per second. Then part B, they are telling us to find the value of R. Now here I have my Q. It has a mass of 0.3 kilograms. Then I have my R here, whose mass is 0.6 kilograms. Okay. Now when Q knocks this one, there is a possibility of it rebounding. Okay. Okay. Then next we shall have again Q 0.3 kilograms. Then we also have R here 0.6 kilograms. Just like before, momentum before collision is equal to momentum after collision. So UQ here is the final velocity we got here. Okay, the speed after collision here is now its initial here. So UQ is 10 m, okay, meters per second, and then UR here, since it is stationary, it is 0, and then they said that Q is brought to rest in collision with R. That means VQ is equal to 0. And then here, the VR is going to be equal to 1.5. Now, MQ, UQ, plus MR, UR shall be equal to MQ, VQ, then plus MR, VR. So the mass of Q is 0.3, then times its initial speed, which is 10 m, and then the mass of R, of course here it is 0 because it is stationary, the U is 0, so everything goes. And then also here, the final momentum for Q is 0 because it was brought to rest, and then here we have 0.6, then times 1.5. So here we shall have 3m, 0.6 times 1.5. Now that is like the same as 6 over 10 times 15 over 10. So this one is 90, then divide by 100, then I get 0.9. So 0.9 here. So what will be our m? M is equal to 0.9 divided by 3, which is going to be equal to 0.3. Can put on kilograms. As simple as that. Question 2. A particle P of mass 0.4 kilograms is projected vertically upwards from horizontal ground with speed 10 meters per second. Okay. And find the greatest height above the ground reached by particle P. So I can have the particle P here. Okay. Then it is projected vertically upwards. It will reach the maximum height and then it will turn back here. Okay. So at the maximum height here, V is going to be equal to 0. So we need this height here. Okay. Since this is vertical motion, then acceleration is equal to the G, the acceleration due to gravity. Now I can just use V squared is equal to U squared plus 2AS. So the final velocity is 0. Then U, it is projected with a speed of 10. So 10 squared, then plus 2. Since it is a vertical projection, then A is equal to negative 10. So that is negative 10 because, acceleration due to gravity acts downwards. Okay. Then times the H. So this is negative 20. It can come this side. It becomes a positive 1, which is equal to 100. So our H is going to be equal to 100 divided by 20, which will give us 5 meters. So that is that. Then they are saying when P reaches the ground again, it bounces vertically upwards, but at the first instant that it hits the ground, P loses 7.2 joules of energy. Part B, find the time between the first and second instants at which P hits the ground. Now, I'm going to draw something small here. Remember, in mechanics, we have to learn the art of drawing. It helps us in interpreting. So it comes down here and then rebounds. Okay? It rebounds. Maybe it ends there. So when it rebounds here, first of all, when we begin here, because U is 10 meters per second, it was projected with 10. By the time it comes here, remember this is 5 meters. Okay, the height here. It comes here, the V is 0, but here it has potential energy, okay, because there is vertical height generated. Then down here, it will have kinetic energy because it will drop here with a certain speed, okay. Then after that, when it rebounds and then reaches this height here where V is 0, it will have potential energy. There won't be kinetic energy there because kinetic energy is dependent on the velocity. So we shall have here maybe H2 here. Let me just put H2 here. There is some maximum height that it is going to reach up to. Okay. Now, the initial potential energy here is converted to the kinetic energy down here. Okay, when it rebounds. So I can say initial potential energy is going to be equal to, remember, potential energy is mgh. So the mass of this particle is 0.4 kilograms. Then times the acceleration due to gravity, which is 10, times the height, which we found to be 5. So this all together gives us 20 joules. Okay. Now, all this potential energy, like I've said here, is converted to the kinetic energy down here. Okay. So the kinetic energy, now, let me just say, all the potential energy is equal to the kinetic energy, okay, on collision with the ground. It has been converted. Okay. Now, after collision, there is loss of 7.2 joules. So now we can say new kinetic energy. It is going to be this 20 joules, then minus the 7.2. And this one will give us 12.8 joules. Now, this is the new kinetic energy the particle is now rising with. But as it is rising with that potential, kinetic energy, it has a certain speed it is moving with. So what is that speed? You know, kinetic energy is a half mv squared. So which is equal to, now this kinetic energy we have gotten 12.8. Okay. So we shall have v, which is going to be equal to the square root. This is 12.8. We shall multiply by 2. Then we divide by m. Okay. The m here. Remember, m is 0.4. So putting this in the calculator, what do we get? Square root of 12.8 times 2. Then down we have 0.4. It gives us 8. So this one is 8 meters per second. Okay. So it rises up with 8 meters per second. They are telling us to find the time between the first and second instance at which P hits the ground. So there is hitting the floor here at first, and then it rises up, then hits here again. So that means we just need to find the time from here to here. Okay. Then we multiply it by 2 because the motion is symmetrical. Okay. This one is symmetrical. So I just need to find the time taken to go up to here. Up here, and then I multiply it by 2. As simple as that. Now using v is equal to u plus 80. The final speed is 0. The initial is this 8 we have gotten. Then plus, since it is going up, then the acceleration is negative 10 of t. So you bring this t, 10t this way, it will become a positive. So 10t is equal to 8. And then t will be equal to 8 over 10, which is 0.8. Okay, 0.8 seconds. So, like I've said, since the motion is symmetrical, then total time taken is going to be that 0.8. The time taken for going up is equal to the time for coming down, so times 2, and this one gives us 1.6 seconds. Simple as that. Number 3, a particle in a straight line starting from rest. The displacement s meters of the particle from a fixed point O on the line at the time t seconds is given by s is equal to t power 5 over 2 minus 15 over 4 t power 3 over 2 plus 6. Find the value of s when the particle is again at rest. Now, this is under variable acceleration, where we are given the expressions for either displacement, velocity, or acceleration. So in this case, we don't use the other 3 equations of motion. The v is equal to u plus at, s is equal to ut plus a half at squared, and then v squared is equal to u squared plus 2as. We use those for constant acceleration. So here we use differentiation and integration. So since they have said find the value of s when the particle is at rest, so at rest it means that velocity is 0. Okay, at rest v is 0. But we know that velocity is the rate of change of displacement. So it is ds dt. That means we are going to differentiate. So velocity is going to be, remember, you drop the power and then you reduce it by 1. So we shall have 5 over 2, then t power. 5 over 2 is 2.5. Then minus 1, you get 1.5, which is 3 over 2. Okay, then minus, we drop this one here, 15 over 4, we multiply it with 3 over 2, and then here you have t. 1.5 minus 1, you get 0.5, so I will have a half here. And then, of course, when you differentiate a constant, it disappears. So this one is going to simplify to 5 over 2, t power 3 over 2. We shall have 45. Okay, 3 times 15, that is 45 over 8 here. Now they are saying this at rest v is 0, so we shall equate this one to 0. Okay, and then we have, I can multiply everywhere by 8. Okay, multiply all through by 8. So when I multiply by 8 here, I get 4 times 5, that is 20, then t power 3 over 2, and minus, this will be 45, and then t power a half, which is equal to 0. Divide all through by 5, we shall get a 4 here, t power 3 over 2, minus 9, then t power a half, which is equal to 0. Now, we have t power 3 over 2, okay, is going to be equal to t power 1, then times t power a half, because you can get 1 plus a half to get this 3 over 2. So that means t power a half is common here. So I can have 4t here and then minus 9. Okay. Then t power a half here is equal to 0, and then 4t minus 9 is equal to 0, meaning our t is equal to 9 over 4, and also t is equal to 0. But they told us that to find the value of s when the particle is again at rest. You see that? Again. So that means it is at rest when t is equal to 0, it is starting from rest, and also it is at rest at this t. Okay, so we substitute now in the expression for s, which is given up there. So that means our s is going to be equal to 9 over 4 power 5 over 2, then minus 15 over 4, and then we multiply by 9 over 4 power 3 over 2, then plus 6. So what do we get? We put everything in the calculator. We have 9 over 4, then power 2.5. Okay, power 2.5, then minus 15 out of 4, then we multiply by 9 over 4, then power 1.5, power 1.5, then plus 6. Then we get 15 out of 16. So s is equal to 15 out of 16. 15 out of 16 meters. You can write it to maybe in decimals. Let's see, this one is 0.9375. So whichever way. So that is that. Question 4. The velocity of the particle at t seconds after leaving a fixed point O is v meters per second. The diagram shows the velocity time graph which models the motion of the particle. The graph consists of 5 straight line segments. The particle accelerates to a speed of 0.9 meters per second in a period of 3 seconds, then travels at a constant speed for 6 seconds, and then comes to instantaneous rest 1 second later. Okay, this is what they have been talking about here. Then the particle then moves back and returns to rest at O at t seconds. Now it is below the the t-axis here, and velocity is negative because the particle is now moving in the opposite direction. It is now coming back where it was, you see? So that is that. And they're telling us to, part A, find the distance traveled by the particle in the first 10 seconds of its motion. Total distance is always equal to area under the graph. If you look at the relationship between speed, time, and distance, distance is equal to speed times time. So if I'm finding the area of this region here, so here I have time, and then here I have the speed. So time times the speed gives us the distance. So that's why area under the graph, okay, is always giving us the distance. So distance traveled, shall be equal to area under the graph, But then when you look at the area under the graph here, we have, it is a trapezium, okay? This whole thing here is a trapezium here in the first 20 seconds. And area of a trapezium, you know, it is a half h into a plus b. So a half into h, a plus b, and our h, that is the 0.9, 0.9. So a half times 0.9, and then our a can either be this smaller one or this bigger one, okay? So we always take this as the a. So 9 minus 3, that is 6, and then the bigger one is this one, the two parallel sides, okay? So we shall have here 6 and then plus 10. So 6 plus 10, that one gives us 16. Divide by 2, you get 8. 8 times 0.9, it will give us 7.2 meters. Part B, given that t is equal to 12, find the minimum velocity of the particle. Okay, minimum velocity of the particle. Now, when this particle returns to O, it travels the same distance. Okay, so the return journey, let me write it here. The return journey is still the same distance. Okay, and when you check what we have here, what we have in this diagram, so the distance we have gotten is 7.2. So we get area of this triangle here. And yes, we know that this one here is a negative value of v, but when we are using area, we are taking lengths. So you will take this length here, this will be the vertical height, okay? But when you're substituting here, the length is a negative, is positive. We don't have negative lengths. But then, since they are asking for velocity, and velocity is a vector quantity, and we can easily see that it is below this t-axis, then we shall bring back that negative in the equation, okay? Now, here the base is t minus 10, and then we are looking for the v, okay? Now let's go back. So we are going to have, that is a triangle, so a half BH will be equal to that 7.2. So it's a half, the base is going to be 10 minus, t minus 10. Already t is 12, so 12 minus 10, you get a 2, okay? So we shall put here 2, and then the height is the velocity we are looking for. So this is 7.2. Automatically, this one is going to cancel that, and then our velocity is going to be equal to the 7.2, okay? But we are going to put that negative there because they didn't ask for speed, they asked for velocity, and it is moving in the opposite direction. Even from here, you can easily see that it is below the t-axis. The value of v is below the t-axis, so it has to be a negative. Then part C, given instead that the greatest speed of the particle is 3 meters per second, find the value of t and hence find the average speed of the particle for the whole journey. We are given the greatest speed, which is equal to 3. Okay, that is our V. Now, I can have my a half BH, which is the area of that triangle. Remember, it is equal to 7.2. Okay, now we shall have a half. Remember here, the base is t minus 10. So if it is t minus 10, then I'll come back here and I put that as my base, t minus 10, then times the height, which is 3, then is equal to 7.2. Then when I cross multiply, I'll have 10 minus 10, which is equal to, t minus 10, which is equal to 7.2 times 2. Then I will divide by 3. And then our t is going to be equal to 3 goes into 7.2, 2.4 times, because 24 times 3 is 72. Then times 2, that will be 4.8. Then we shall add this 10 when it comes this side. Okay, so plus the 10, that means t is going to be 14.8. Then they told us to find the value, and hence find the average speed. You know that average speed is equal to the total distance traveled over the total time taken. So average speed is equal to total distance traveled divided by the total time taken. And the total distance is actually 7.2 going forward and then coming back. So you multiply it by 2. Then we divide by the total time t, which is 14.8. And then what do we get when we put in the calculator? So we shall get 7.2 times 2 divided by 14.8. We get 36 over 37. Then to 3 significant figures, you can write 0.973, but I'm going to leave it as a fraction. Okay, over 37, then meters per second. That is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.